Here we are in the South Jersey coastal salt marshes near Avalon. As you can see, they go on for miles. So they're mostly made up of cordgrass, but this is the best spot I've found to find Salicornia. This is the species that we're going to be reintroducing in Syracuse. This is Salicornia depressa, slender glasswort. And as you can see, a pretty easy way to tell it from Salicornia ambigua is that this is an annual, so it's totally dead and it was only ever one individual. And it has pretty slender stems. It's hard to tell, these are obviously desiccated, but we're going to be collecting some sediment from underneath these. Alright, here we have a really nice stand of Salicornia ambigua. It's everything that's dark in this frame. And here you can see that this is Salicornia ambigua because you've got these, let me see if I can get this to... You can see the new growth coming up. One other way you might be able to tell Salicornia ambigua is most of the time these stems are going to be really not branching at all. So you'll have a big branching clump of rhizomes underground, but the above ground section is pretty much going to be really singular spikes. As opposed to Salicornia ambigua, Salicornia depressa is highly branched. Alright, here's another nice specimen of Salicornia ambigua, the perennial saltwort. So it's early March right now, and you can see the last year's growth. It's dried and dead, and then closer to the base, it's starting to have some nice new growth. I tore this one up, and you can also see the underground rhizome, horizontal underground stem. Here we are at the East Loop Road Inland Salt Marsh, constructed by Upper Susquehanna Coalition and TWT, completed last August. So why would we even try to make something like that, an inland salt marsh? And it's because about 410 million years ago, this region was covered by a shallow hypersaline sea that precipitated salts and formed a thick layer of halite, which is responsible for the salt extraction industry in Syracuse. And where that layer of halite interacts with aquifers, it actually brings up hypersaline water to the surface. So what's unique about this site is we have one of those springs located on the site, and the salinity of the spring is about 3 or 4 times the salinity of seawater. It historically flowed into this ditch, which leads into Crane Brook a little bit up there. Right now it's actually connected to the sea, to the ditch, but we can also connect it to the site. We'll show you the control mechanism. So here's the control mechanism for the spring. So we've got 2 stainless steel paddle valves on 6-inch PVC. This one is open right now, contributes to the ditch that goes into Crane Brook, and the one that's closed right now contributes to the site. This way we've got hydrologic control over the site and probably be able to imitate some of the hydrological features of inland salt marshes. So the site's in a drawdown right now to try to open up some habitat space for exposed soil because we intend to do seed plots. But soil salinities are ranging from 5 to about 35 decisiemens per meter, which is extremely high. glycophytes or salt intolerant species, the majority of species, are excluded at about 3 decisiemens per meter. So there's very high soil salinities on site that should create an interesting gradient of soil salinity to investigate with our Salicornia and other plots. So the site was completed in August of last year. For about a century it had been mixed use agricultural, but abandoned for the last 30 years or so. So some pretty hairy kind of old field vegetation, and they came in, cleared it all out with machines, and then they shaped the basin with backhoe and a dozer, and they actually took the dozer and removed about 12 inches of topsoil all across the site. So the site is just clay right now, extremely nutrient limited, so nutrient poor, and that's to try to imitate the natural conditions of inland salt marshes. The second thing that they did, which is interesting, is they did topsoil compression with a roller across this entire site to try to keep it holding water. And that's not something that you'd normally do. Normally you would pick a mitigation site because its landscape position and hydrology are already really favorable for creating a wetland or hydric soils. But the saline spring on this site is just so rare and kind of valuable that we're trying to, I wouldn't say cheat it, but kind of force the hand for hydric soil conditions, and it seems to be working pretty well so far. So right now it's before we've planted anything, and so this is kind of a good time to see where the influence of salinity, it's really weird how stark it is. All around the site we've got a lot of grasses coming up and stuff, and where that is, where the soil salinity is exclusionary is just like a line. And this is true throughout the entire site. There's absolutely nothing on this site growing inside of that line right now. It is just a big old mud pit. So this is the propagation station that we have going in the greenhouses for Salicornia. And we've got a couple methods that we're trying to propagate the species from seed by. The first one is that I had sediments. Not sediments, I had seed from last year that I took from standing crop in my backyard. They were cold stratified for 30 days in the walk-in freezer downstairs, and then they were spread out on a coarse media with a little bit of vermiculite on top to maintain moisture. And it took a while, but we're starting to see some come up. I don't know if you can see, but yeah, so they're very small, and that's really when you want to transplant them. So the other way that we're doing this is we are propagating from sediment that I collected over spring break. So we've got a couple trays of sediment here, and these are already taking off to the point where it might not be worth it to transplant them because their root system is already going to be pretty robust, and they have a very fibrous, delicate root system, and we don't want to damage that. So these maybe will, there are a lot of really small ones still coming up that we can transplant, but the really big, large ones, maybe we'll just keep those to eat or something. And so what's really cool about this species is you can harvest a lot of the crop and just leave 10 plants or so behind, and they will go fully to seed, and each one of them will drop many hundreds of individual seeds. So you really don't need, once you get this going, it has a pretty tremendous inertia. You don't really need to maintain it that much. And the other thing that we've done, actually to improve some flaws from last year, is made a few water boxes. So Salicornia is an obligate wetland species. It really doesn't have any problem with saturated soil, and watering, especially trying to be here every day to water it, is sometimes problematic. So for wetland species, a lot of the time in restoration projects, they'll put trays into water boxes. So these are just 2x4 frames with I think 6mm plastic sheeting, double wrapped over it and stapled onto the frames. And this has been keeping the soil really moist for our trays of sediment, and they've been just taking off. I just took these out, but they're really doing pretty well. So let's try to propagate. What you want to do when they're this small, you can actually just pop them right out. And this is why you have to get them when they're small. So take one of these, and it comes right out. Extremely small. Most of the time you're just going to see a radical, maybe a little bit of extra rooting, but that's the best time to remove them without damaging the root system and ensuring a pretty safe transplanting process. So now we go to our trays, and I tend to just do a little hole like that, and they are kind of hard to work with because they're so teeny. And then you just pop it in there and slide all the soil around it, and that is a good looking transplant. And that's what we're going to be doing on a much smaller scale in lab on Monday.